Good morning, dear students. Welcome back to physics class. Today, I would like to present second experiment, which is from the same chapter, units and measurement. The experimental topics are A. To measure diameter of a given wire using screw gauge and find its volume, and B is to measure thickness of a given sheet using the screw gauge. What is the aim for this experiment? Aim is A. To measure diameter of a given wire using screw gauge and find its volume, and B. To measure thickness of a given sheet using the screw gauge. Theory part is the screw gauge is an instrument used for measuring accurately the diameter of a thin wire or thickness of a sheet of metal. It consists of a U-shaped frame fitted with a screw spindle which is attached to a thimble. What is spindle? Spindle means the metallic rod which is in round shape with tapered ends. What is thimble? Thimble is a metallic cap with closed end. Let's have look into the subject, how to describe each part of a screw gauge. Parallel to the x-axis of the thimble, a scale graduated in millimeter is engraved. This scale is called pitch scale or linear scale. The head of the screw has a ratchet which avoids undue tightening of the screw. It is a device which allows the screw to move in one-dimensional way. On the thimble, there is a circular scale known as head scale, which is divided into 50 or 100 equal parts. In general screw gauge, it will be 100 equal parts. When the screw is worked, the head scale moves over the pitch scale. A stud with a plain end surface called the anvil is fixed to the U-shaped frame exactly opposite to the tip of the screw. When the tip of the screw is in contact with the anvil, usually the zeroth division of the head scale coincides with the zeroth division of the pitch scale. On next, you have to understand about the pitch of the screw gauge, which is used to calculate its least count. What is pitch of the screw gauge? Pitch of the screw gauge is defined as the distance traveled by the tip of the screw for one rotation or revolution made. To find this, the distance advanced by the head scale over the pitch scale for a definite number of complete rotation of the screw made is determined. Let x be the distance traveled by the tip of the screw for n rotation or revolution made. Then the pitch will be equal to x by n. Pitch is represented by P, which is equal to distance moved by screw by number of full rotations given, which is the equation number 1. What should be its least count? Least count is the distance moved by the tip of the screw when the screw is turned through one division of the head scale. It is the smallest measurement which can be made accurately with the help of this device. From the definition of least count of the screw gauge I told earlier, the least count of the screw gauge can be written as LC is equal to pitch divided by total number of division on the head scale or the circular scale. So, The least count can be calculated using the formula least count LC is equal to pitch divided by total number of divisions on the circular scale or head scale, which is the equation number 2. As I told earlier, every measurement will have error. In case of screw gauge, the error will be zero error, and there should be the correction which is called zero correction. The same kind of error was seen in vernier calipers also. To get the correct measurement, the zero error must be taken into account. For this purpose, the screw is rotated forward till the screw just touches the anvil and the edge of cap is on the zero mark of the pitch scale. When this is done, any one of the following 3 situations can arise. Let me see what are the 3 situations. First situation is the 0th mark of the circular scale comes on the reference line. What is the reference line? It is the index line which has drawn along the pitch scale. In this case, the zero error and the zero correction both are nil, which is the case number 1 as shown in first figure. In second case or situation, the 0th mark of the circular scale remains above the reference line and does not cross it. In this case, the zero error is positive and the zero correction is negative, depending on how many divisions it is above the reference line. As it is positive error, correction is negative, the correction E is equal to minus N into LC. If it has done 3 trials to find its arithmetic mean, then the correction E is equal to E1 plus E2 plus E3 whole divided by 3. And the third situation or case is the 0th mark of the head scale is below the reference line. In this case, the zero error is negative and the zero correction is positive, depending on how many divisions, that is N, it is below the reference line, which is shown in figure 3. So, its correction is equal to plus N into LC. Here, the correction is positive as the error is negative. And also find its arithmetic mean. Let me see how to find the diameter and hence to calculate the volume of the wire. First, we have to place the wire between the anvil and the screw. And if the edge of the cap lies ahead of the nth division of the linear scale or pitch scale, note down the PSR, which is pitch scale reading. Then pitch scale reading or linear scale reading is equal to capital letter N. If nth division of circular scale lies over reference line, so head scale division HSD is equal to small letter n. Then circular scale reading or head scale reading HSR is equal to HSD into LC, where HSD be head scale division, which is equal to small letter n into LC, where LC be the least count of the screw gauge. Then the diameter of the wire is given by total reading TR is equal to PSR plus corrected HSR. What is the corrected HSR or head scale reading? If the screw gauge is having zero error, we should take account of the correction which you had seen in previous section. If the error is positive, correction should be negative. If the error is negative, correction will be positive. These errors are the zero errors. So the corrected HSR is equal to observed HSR plus or minus the zero correction. Then total reading TR is equal to N plus small letter n into LC, which is the equation number 3. If R is radius of the wire and L be the mean length of the wire, then what should be its volume? The volume of wire is equal to V is equal to pi R square L, which is the equation number 4. On next, you see how to find thickness of a metal sheet. The metal sheet is gripped between the tip of the screw and the anvil. The PSR and HSR are noted as before. The thickness of the metal sheet is T is equal to PSR plus corrected HSR, which is equal to capital letter N plus small letter n into LC, which is the equation number 5. What is principle of screw gauge? You should note this point. Principle of a screw gauge is screw in nut. It works under the same principle of screw in nut. Screw can move through nut or vice versa because of they are having spiral shaped cut thread, which may be either on their inner or outer surface. For the screw, it will be there on outer surface, and for the nut, it will be there in inner surface, so that one can move through another. For example, I give one question you which help how to perform on measurement using screw gauge. The diagram shows part of a micrometer screw gauge having 50 divisions in the head scale. What is the reading shown? From this figure, edge of the cap or head scale lies between 3.5 and 4.0 division on pitch scale. Then we have to take lower division, it is 3.5. So pitch scale reading is 3.5 millimeter, since one division on pitch scale or 1 PSD is equal to 1 millimeter. Then what is HSD? Here 11th division on head scale coincides with the reference line or index line. So HSD is equal to N is equal to 11. Then total reading is equal to PSR plus HSD into LC, which is equal to 3.5 millimeter plus 11 into 0.01 millimeter is equal to 3.50 millimeter plus 0.11 millimeter is equal to 3.61 millimeter, which is the answer. Which of the materials should need to do this experiment? Materials are screw gauge, a wire, a metal sheet, etc. What should be the procedure? First, we have to determine the pitch and the least count of the screw gauge using the equations 1 and 2 respectively. After, bring the anvil and the screw in contact with each other and find the zero error. Do it 3 times more and record them. If there is no zero error, then record zero error as nil. Then after, move the screw away from the anvil and place the wire and move the screw towards the anvil using the ratchet head. Stop when the ratchet slips without moving the screw. Note the number of divisions on the pitch scale that is visible and uncovered by the edge of the cap. The reading capital letter N is called the pitch scale reading or PSR. Note the number N of the division of the circular scale lying over the reference line, which is HSD, head scale division. Find the total reading using the equation 3 and apply zero correction in each case. And its mean value should be calculated. You have to note that you can place the other object like metal plate between the screw and the anvil and follow the same procedure to find its measurement. It is for the second part of our experimental aim. Let us see the observation part. First, we have to determine least count of the screw gauge. One linear scale division or 1 LSD is equal to 1 millimeter, which is also called pitch scale division. One pitch scale division is equal to 1 millimeter. Let number of full rotations given to the screw be 4 and the distance moved by the screw be 4 millimeter. Then pitch of the screw is equal to distance traveled by the tip of the screw divided by number of rotation made, which is equal to 4 millimeter divided by 4 is equal to 1 millimeter. You know that total number of division on circular scale in common screw gauge is equal to 100. Hence, least count of the screw gauge LC is equal to pitch divided by number of division on head scale of the screw gauge is equal to 1 millimeter divided by 100 is equal to 0.01 millimeter. When it converts into centimeter, which is equal to 0.001 centimeter. And also should mention the zero error of the screw gauge if any, and its zero corrections in the observation column. As I told earlier, if the screw gauge is having zero error, you should find their zero corrections and also calculate their arithmetic mean. Then, mean zero correction C is equal to E1 plus E2 plus E3 divided by 3. Here we have done 3 trials, so it will be equal to minus or plus E, which is in millimeter. After you have to convert into centimeter. This slide shows the tabular column for your observations. Object placed are first wire and second one metal sheet. In each case, there are 5 trials made. In this slide, both calculations and result are made. First, for the calculation part, mean diameter of the wire, which is in centimeter, the volume of the wire, which is in centimeter cube, and thickness of the metal sheet, which is in centimeter. And for the result, diameter of the given wire, which is in centimeter, the volume of the wire, which is in centimeter cube, and the thickness of the given sheet, which is in centimeter. Dear students, today I am giving you some experimental Viva questions. Kindly please, you have to practice these questions. Okay, thank you. Have a nice day.